I'm going to discuss this very important question. How are materials linked to the sustainable development? And this is basically a crash course in life cycle thinking. And also, I'm going to show you quite a bleak, dark picture of the state of the planet. But there is hope, of course. So I'm going to talk about what can we do as engineers and researchers. So let's begin. Sustainable development. The definition: sustainable development is development that meets the needs of the present without compromising the ability of future generations to meet their own needs. This is from the Brundtland Report in 1987. This is basically what everybody agrees upon. Then there is many different aspects of what is sustainability, or what is development even. So this is not by no means an easy task. There are three aspects of sustainability. You have the economic, the social, the environment. And all these combined is a part of sustainability. This is one way to picture the three aspects, where you have the sweet spots of sustainability here with the three parts combined. However, I believe that this is a more accurate picture and more important, since economy is a part of society, and society is embedded in the environment. This is more clear that we are all dependent on the natural capital, our planet. And this is from Scott Cato in 2009. Sorry. No. So these are the 17 Sustainable Development Goals of UN, and all the three aspects are combined in these. So you have the social issues, you have the economic and the environmental issues, and everything is connected. So what we're going to do, we're going to follow a product throughout the life cycle. I'm just going to go through the life cycle so you know what I'm thinking of, talking about. So you start with a raw material extraction. You need all kinds of minerals and things to then manufacture your product. Transportation is something that reoccurs between all life phases. Then you have the use of the product, and finally the end of life, some kind of disposal or maybe recycling of the product. And throughout this life cycle, you have inputs and outputs to the natural capital. You have inputs in form of material, energy, and you have outputs in form of emissions to air, soil, and water, and all kinds of waste. So this is the life cycle. We're going to follow a product throughout it. So this is what raw material extraction could look like. This is a coal mine in US. So you have modern equipment with very very much safety thinking and so on. But of course, all kinds of mining leaves scars on the planet. This is an open mine, gold mine in Australia. So you see, there's a lot of impact on the planet. Gold is very important for our high-tech products, but there's also a lot of different other materials that are really important for our high-tech products. For example, tantalum, wolfram, neodymium, and so on. But they come usually from Congo, Kinshasa. So here you have men and children mining these very valuable materials. And as you can see, they use very simple tools, and there's some issues about safety, uh, child labor, wage, human rights, and so on. So there's no wonder these are called conflict materials. There's also a group called critical raw materials, which means that they have a high economic importance and they have a supply risk. So these are the materials that are defined by EU in 2014 to be the critical raw materials, very important for EU. There's a new list that came out recently, so they added also nine new elements. So, for example, we need these materials for our smartphones. We need the wolfram, we need the neodymium, and so on. You can see the red ones are the critical materials. So products are getting more advanced and needing more and more materials. And these are some other products that we need our materials for. We need high-tech products, we need super alloys, we need more efficient batteries, and so on. So very dependent on materials for our high-tech society. Now we come to manufacturing. This is a manufacturing facility in Leipzig in Germany. You have robotic automation of welding of the car chassis. So very clean and nice. But also there's a drawback to manufacturing. For example, all kinds of not so humane working conditions, low wage maybe, long working hours. I would say this is a part of why we have so much cheap products. They do the working for us. Now, there's transport between all life phases, as I said. The transport could be made by air, by sea, by rail, or by road. And we transport a lot of products. This is a picture of how the density of commercial shipping. So this is just shipping. As you can see, there's a lot of goods moving between Americas, EU, Europe, and Asia. So, and it would be even more if I added road and air travel. So, we are encouraged to buy more products, and it's cheaper. This is a long-term price trend of electronic goods and services. From 1997, you can see that basically everything is getting cheaper, except for some cable and satellite television and radio services, apparently. So we can buy more stuff. It's more cheaper to buy a new product than to actually try to fix a broken one. And then we come to the use phase. Depending on what kind of product it is, you need to have some kind of energy, fuel, maybe some kind of cleaning. So this is the input to the life phase. And you have outputs in form of emissions to water, air, and soil, and all kinds of waste. So, for example, if this is a car, you might need petrol, and you have carbon dioxide as an emission. Or is it a washing machine? Then you need electricity, and you have dirty water coming out as an emission. Just an example. Then, after the use phase, the product is disposed. And it's very important to remember that this does not just happen when the product is broken or spent. This could happen because the product is outdated. You don't have enough space on your phone, for example, or it's not up to fashion trends, or it's dirty, or you'd find it very ugly. So this is where products end up. And one of the problems is that the life phase is moving faster and faster. The life cycle is shorter. So we end up with mountains of waste. So this puts a great strain on the disposal system. For example, in this case, e-waste. So in any product, there's a huge blend of very critical materials that we don't extract. Of course, there's really bad waste management also. Incineration in open air, dumping of waste. For example, illegal waste trade is one of the most growing illegal trades in the world. It's going to actually outgrow drug trade because you have low penalties, you have high potential gain in money. So, too bad. So, we don't have a closed circle yet. There's still a lot of work to be done. But this is the aim we're going for. We want to close this circle and be more efficient. We have emissions to air throughout the life cycle. It could be, for example, this is the brown cloud that hovers over Asia. You have smog. Particulates in air is the cause of millions of people dying each year because of more heart diseases, lung diseases, and so on. So, not good for humans, not good for plants, not good for animals. You have emissions to water. You have the obvious littering of plastic bottles, of nets, of oil spills. But then you also have the more hidden emissions of microplastics that end up in the planet. Then you have emissions to soil, oil leaks, pesticides, unmonitored landfilling. So, of course, we end up with environmental impacts, social impacts, economic impacts. So, we have a lot of impacts throughout the whole life cycle on different aspects of sustainability. Can we do anything? Of course we can. Otherwise, I wouldn't be here. So, what I work with and my colleagues, we try to design more sustainable products. And we use tools like Lifecycle Thinking. We use ecodesign or design for environment. There's many more, but these are the things I'm going to present for you. So, Lifecycle Thinking is basically, as you might recognize, very the life cycle of a product is basically that you should optimize the use of all resources and minimize the output of landfilling and the lost resources. And also energy should be included in this one. So in each and every state, you must optimize. And also very important, when you design a product, that you actually have a plan for it throughout the whole life cycle. You have a plan for what materials to use, what production processes to use, how it's used during the use phase, and how it will be end of life managed. Will it be recycled, reused, or what? That you should actually have a plan for the whole product. Just a few words about evolution of material science. Some 50 years ago, material science was a separate knowledge of materials, plastics, and ceramics. Very different. Today we talk about material science. We talk about structures, about design, about very much more complex situations. And we're getting there. We're talking about materials in an atomic scale to a more global scale, since we also have to include trade of materials and products. So what we might talk about today is material systems and design, where we include aspects of social economy and environment, sustainability, as we talked about. So materials is very much connected to sustainability. So the choice of materials affects the processes, affects the energy, the regulations, the nations. Everything is connected. I get happy every time a student tells me, it's not just to pick a material, there are consequences. Then I feel like, yes, they get it. So, why should we have longer lifetime for a product? Imagine you have this very nice light blue product. There's no service, there's no maintenance, it's very cheap. You use it for about 2 years, and then, you discard it because it's dirty and doesn't work as well. Compared to this blue one, it's included maintenance, service. You might use it for 12 years. So to have the same use time, you need 6 of the more cheaper one to have the same lifetime as the more expensive one. So as you see, cheaper products tend to put a bigger strain on waste management. As you can see in this waste management hierarchy, the prevention, the minimization, the reuse of products is more favorable. You also have recycling and energy recovery, for example, through incineration. And the least favored option is disposal. It might be landfilling, where the products are lost. So we need to prevent waste. So, to conclude, this is our only source of resources. This is our only home today. There is a huge problem, is that we live like this. We use the planet as we had 1.6. It's even worse in Western countries. For example, Sweden uses 3.8 planets. So we don't live a very sustainable life. But I think we can do better. And this is what I work with, and which I hope to see in the future very soon. And for hopefully the future viewers, this will just be a horrific, historic memory of how it used to be. Thank you.